All right, guys, welcome to the read aloud for the history behind weather forecasting. This is the website I want to use to read the content. It's the National Geographic website. Sorry about that. And this is what it should look like. You should see a big picture of lightning bolts, and on the left-hand side, you should see a little description. Before you read, I would definitely go through these pictures and read the descriptions because they're quite interesting. So if I just click on the right arrow, I can see the next picture of a weather balloon, and I can read a little bit about it, okay, on the left-hand side here. So what I want to do to find the history behind weather forecasting, that's the section I want you to read. I see my scroll bar on the right-hand side here, this little gray bar. I want to scroll down until I'm a little bit before halfway. And when I'm scrolling, I want you to notice that there's different sections. So in bold letters, the section below underneath here is called weather systems. And if you would like to read this, that's fine. We talked a little bit about it already. But if you are interested, feel free to do that, okay? But this is the section that we want to find. I'm going to stop here. The history behind, or the history of weather forecasting. So what I'm going to do is I'm going to read this whole section, just the section aloud for you, and I would like you to follow along. And this section is important because eventually we will be taking an open notes test on weather, and I will include a few questions from this section of the history of weather forecasting. So I'm going to start here. Meteorology is the science of forecasting weather. Weather forecasting has been important for civilizations for thousands of years. Agriculture relies on accurate weather forecasting, when to plant, when to irrigate, when to harvest. Ancient cultures from the Aztecs of Mesoamerica to the Egyptians in Africa and Indians in Asia became expert astronomers and predictors of several weather patterns, seasonal weather patterns. Of all these cultures, weather forecasting became associated with religion and spirituality. Weather such as rain, drought, wind, and cloudiness were associated with the deity or god. These deities were worshipped in order to ensure good weather. Rain gods and goddesses were particularly important because rain influenced agriculture and construction projects. I'm not sure how to say that word. An Aztec tribe, an Egyptian tribe, an Indian tribe, as well as Thor, Norse, Zeus, Greek, and Shango are some gods associated with rain, thunder, and lightning. Developments in the 17th and 18th centuries made weather forecasting more accurate. The 17th century saw the invention of the thermometer, which measures temperature, and the barometer, which measures air pressure. We already talked about the barometer a little bit. In the 18th century, Sir Isaac Newton was able to explain the complex physics of gravity, motion, and thermodynamics. These principles guided the science of meteorology into the modern age. Scientists were able to predict the impact of high-pressure systems and low-pressure systems, as well as weather events as storm surges, floods, and tornadoes. Since the late 1930s, one of the main tools for observing general conditions of the atmosphere has been the radio sonde balloon, which sends information needed for forecasting back to Earth. Twice each day, radio sondes are released into the atmosphere from about 1,000 locations around the world. So 1,000 locations around the world. The U.S. National Weather Service sends up radio sondes from more than 90 weather stations across the country. A weather station is simply a facility with tools and technology used to forecast the weather. Different types of thermometers, barometers, and anemometers, that might be a new one, which measure wind speed. So anemometers measure wind speed, are found at weather stations. Weather stations may also have computer equipment that allows meteorologists to create detailed maps of weather patterns and technology that allows them to launch weather balloons. Many weather stations are part of networks. These networks allow meteorologists from different regions and countries to share information on weather patterns and predictions. In the United States, the Citizen Weather Observer Program depends on amateur meteorologists with homemade weather stations and internet connections to provide forecasts across the United States. The Aircraft Meteorological Data Relay, also known as AMDAR, that's an acronym, so that's what it stands for, also assists in gathering weather data directly from the atmosphere. AMDAR uses commercial aircraft to transmit information about the atmosphere as the planes fly through it. So perhaps if you ever were on an airplane, that airplane was observing and collecting data and then reporting it back to meteorologists so they could make a more accurate forecast. So here we are, I'm at weather balloons. Weather balloons and AMDR instruments gather information about temperature, pressure, humidity, and wind from very high levels in the atmosphere. Meteorologists input the data to computers and use it to map atmospheric winds and jet streams. Remember, we talked about jet streams already, what they are. So they're those kind of rivers of super fast winds really high in the atmosphere, and they can influence weather on a daily basis. Okay, so jet streams are one of the last factors that can influence weather. So here we are, I'm at they often. They often combine this data about temperature, humidity, and wind recorded at ground level. These complex weather maps use Geographic Information Systems, GIS, technology. Using GIS technology, they can calculate how weather systems are moving and predict how they might change. This type of forecasting is called synaptic forecasting. Synaptic forecasting is getting a general idea of the weather over a large area. It relies on the fact that in certain atmospheric conditions, particular weather conditions are usually produced. For example, meteorologists know that a low-pressure system over the U.S. state of Arizona in winter will bring warm, moist air from the Gulf of Mexico towards Colorado. The high-pressure weather system of the Rocky Mountains drains the water vapor out of the air, resulting in rain. Meteorologists know that heavy snow may result when that warm air mass heads towards Colorado. Businesses such as ski resorts rely on such information. Transportation networks also rely on synaptic forecasting. 2 more paragraphs here. If meteorologists knew more about how the atmosphere functions, they would be able to make more accurate forecasts from day to day or even from week to week. Making such forecasts, however, would require knowing the temperature, atmospheric pressure, wind speed and direction, humidity, precipitation, and cloudiness at every point on the earth. It is impossible for meteorologists to know all of this, but they do have some tools that help them accurately forecast weather for a day or two in advance. But because the atmosphere is constantly changing, detailed forecasts are for more than a week or two will never be possible. Weather is just too unpredictable. We still have more on this website, so we will eventually be talking about some other types of weather tools like weather satellites, so feel free to look over the rest of this if you'd like. You can read about Doppler radar, which we kind of already mentioned in a previous assignment. You can read about making a weather forecast, more accurate forecasts. Okay, so feel free to look over this if you'd like.